Hello and welcome. Today, we're going to take a journey deep inside the most incredible engine you'll ever own, your own heart. We're going to peel back the layers and really understand the elegant mechanics that keep this thing running beat after beat.
Think about that number for a second. Over 100,000 times every single day. It's just mind-blowing. But what is that familiar thump-thump we all know? I mean, what's really happening on a mechanical and even an electrical level to make it all work? All right, let's get into it.
So first things first, let's start with the big picture, the basic blueprint. Because the most important thing to get right off the bat is that your heart isn't just one pump. Nope, it's actually two separate pumps working in perfect, beautiful harmony.
Okay, so the heart is basically split right down the middle. You've got the right heart, and its whole job is the pulmonary circuit. It sends blood on a quick trip over to the lungs to get oxygenated. Then you've got the left heart, which handles the systemic circuit. It takes all that fresh, oxygen-rich blood and pumps it out to literally the rest of your body. And each of these two pumps has a smaller primer pump, the atrium, which loads up the real powerhouse, the ventricle. All right, now that we have the layout, let's zoom in a little bit. Let's look at the actual material this engine is made of. Because cardiac muscle, it's not like the muscle in your arm or your leg. It is a very, very special, highly specialized fabric. And the difference is just huge. Look, a skeletal muscle, like your bicep, gives you a really short, quick twitch. But cardiac muscle? It gives this long, powerful, sustained contraction. It even does this cool twisting, kind of ringing motion to get every last drop of blood out. But its most critical property, the real game changer, is that it acts as something called a syncytium. So what on earth is that? A syncytium basically just means that all the individual muscle cells are so tightly connected that when one cell gets the signal to go, that signal spreads like wildfire to all the other cells. They all contract together as one single powerful unit. You know, a great way to think about it is like a crowd at a stadium doing the wave. One person starts it, but the whole section moves together seamlessly. That's exactly how the heart gets such a powerful, unified pump. And now we get to the real secret, the core of it all. We keep talking about this long, powerful squeeze of the heart muscle, but what actually creates it? Well, the secret lies in this tiny, microscopic electrical event called the action potential. This is the spark that starts the engine.
And this chart just lays it out perfectly. I mean, look at that. A skeletal muscle twitch is over and done in about 0.02 of a second. Blink and you'll miss it. A single cardiac muscle contraction, though, it lasts for about 0.3 of a second. That's 15 times longer. And that long duration is absolutely essential. It gives the heart enough time to actually push the blood out of its chambers.
So yeah, that's the big question, isn't it? How in the world does the heart muscle manage to hold that contraction for so long when other muscles just can't? Well, the answer is hidden in the unique shape of its electrical signal. Let's just walk through this real quick because it's fascinating. It's all about tiny charged particles called ions moving around. In phase 0, bam, fast sodium ions rush into the cell, creating that initial spark. But here's the magic trick. Phase 2, the plateau. Instead of just resetting right away, these special slow calcium channels open up. Calcium ions start to flow in, and that keeps the cell in a positive, contracted state for way longer. That plateau is the whole secret. Then in phase 3, the calcium channels close, potassium rushes out, and the cell finally resets, ready for the very next beat. Okay, so we've got the electrical spark, we've got the long contraction. Now let's zoom back out and see how that spark translates into the physical action of one single, complete heartbeat. We call this the cardiac cycle.
So every single beat follows these 4 steps. First, during what's called diastole, the ventricles just chill out and fill up with blood. Then, isovolumetric contraction. The squeeze begins, building up pressure like you're making a fist, but all the valves are still closed. Next, ejection or systole. The exit valves fly open and blood is powerfully shot out. And finally, isovolumetric relaxation. The valves snap shut, the muscle relaxes, and it gets ready to do the whole thing all over again.
So how good is this pump at its job? Well, it's pretty darn efficient. With every single beat, a healthy heart pushes out about 60% of the blood that was in the ventricle. That number is called the ejection fraction, and is one of the key things doctors look at to see how well your heart is pumping. And hey, remember those little primer pumps, the atria? They have a super important role to play. While most of the blood, about 80%, just flows passively down into the ventricles, the atria give this final coordinated squeeze called the atrial kick. It's what delivers that last 20%, basically topping off the tank right before the main event.
Okay, so we've got this amazing self-powering pump. But think about it. Your body's needs change all the time. 1 minute you're sleeping, the next you're sprinting for a bus. The heart has to adapt instantly, and it has this incredibly elegant control system to do just that. The first layer of control is actually built right into the muscle itself. It's called the Frank-Starling mechanism, and the idea is actually really simple. Think of a rubber band. The more you stretch it, the more forcefully it snaps back, right? Well, it's the exact same with the heart. The more blood that flows in and stretches those muscle fibers, the more forcefully they contract to pump all that blood right back out. It's a brilliant, automatic, built-in regulation system.
Now, on top of that, you've got external controls coming from your nervous system. The best way to think about this is like a car. The sympathetic nerves are the gas pedal. They rev the engine up, increasing both how fast and how hard the heart beats. This can literally double or even triple your cardiac output. And then you have the parasympathetic nerves, mostly the big vagus nerve. And that's your brake pedal. It slows the heart rate down, reducing output when it's time to rest and relax. So you see, the big takeaway here is that the heart isn't just some dumb pump. It's an incredibly intelligent engine, and it's also a highly sensitive sensor. It's constantly listening to what your body needs and adjusting its performance in real time. From the simple stretch of its own walls to complex signals from your brain, it's this beautiful, dynamic control system. So the question to leave you with is this: what is your heart sensing from you right at this very moment?